Our first problem statement is the radius vector of a rotating particle r equals to 2i plus 2j minus k meter and applied force are 6i plus 3j minus 3k Newton. I have to determine the torque. We know torque tau equals to solve this, we'll use the formula torque tau equals to r cross f. R is the radius vector and f is the force, applied force. So here we can find out our r radius vector is 2i plus 2j minus k and our force is 6i plus 3j minus 3 of k. And we know we have to cross multiply this whole product of vectors. So if I now uh, use the cross multiplication, we know to use cross multiplication we use uh, determination. So this is our I, this is our j, this is our k. For r we will write 2 plus 2 in our j is minus 1, and for f we will use 6 3 minus 3. Now we will use the formula for determination. It will have I equals to 2 into 3 minus 1 into 3 minus of j, and we will write 2 into minus 3 2 into minus of 3 minus 1 into 6 plus k of, this is our I, this is our j, this is our k of, you write this thing in there, k of 2 into 3 minus 2 into 6. So if I calculate this thing, I will find out this is actually equals to 6 minus oh sorry, that will be minus 3, 2 into minus 3, that will be actually equals to 2 into minus 3. So here we will find out this thing as minus of 3i, that will be 0, and here we will find out a minus of 6k, minus of 6 of k. So this is the torque of our given statement. So if I find out the modulus vector of torque, so magnitude, so if I find out the magnitude of tau, it will be equals to root over of minus 3 whole square plus minus 6 whole square, which is actually equals to root over of 45, root over 45. So this is the actual value of our torque, and this is the magnitude of this torque tau. So we solve our first problem. Now another problem we will solve. We will see. This is a wheel weighing 5 kg and radius of gyration about an axis of 0.2 meter. So it says that a wheel weighing 5 kg. So the mass of our wheel is 5 kg and radius of gyration about an axis is 0.2 meter. We represent radius of gyration as k, so it is equals to 0.2 meter. So what is the moment of inertia? We have to find out what is the moment of inertia. We know for moment of inertia I equals to mk square. I equals to mk square. Here our m is 5 kg and k is 0.2 meter. So here we will find out I equals to 0.2. If I calculate whole value, I will find out 0.2 kg meter square. So this is the value of our moment of inertia. We find out our moment of inertia. And there is another thing we have to calculate. In order to produce an angular acceleration, in order to produce an angular acceleration of 2 radian per second. So our second part is we have to produce an angular acceleration of about of 2 radian per second square. In the wheel, what magnitude of torque is to be applied? So now, to create this acceleration, what will be our torque, magnitude of the torque? We know a formula, a relation between a torque and angular acceleration is torque tau equals to I alpha. I alpha. In our first part, we find out our I is 0.2 and we have to create an angular acceleration of 2 radian per second square. 2 radian per second square. So from that, we will find out 0.4 kg, not kg, sorry, it is Newton meter. Newton meter. So this is the torque we have to tau, or the torque, magnitude of the torque will be created when an angular acceleration of 2 radian per second is applied on that wheel. So we will solve our second problem. Now coming to the third one, it says that a uniform circular disc of mass 100 kg. So here we find out our mass m equals to 100 kg and of radius of 20 centimeter. So our radius r equals to 20 centimeter. We take this as meter. It will be 0.2 meter. Oh, this is not 100 kg. This is 100 gram. So 100 gram, it will be actually equals to 0.1 kg. So a uniform circular disc of mass of 100 gram and of radius of 20 centimeter is acted upon by a torque consisting of two equal and opposite force applied tangentially to the rim of the extremities of a diameter. It says that it means, suppose this is the disc, this is the disc. Okay, wherever the axis, the second part is the disc is free to rotate about an axis passing through its center and disc passing through its center. So our axis is in the center, So this is our rotating axis. This is our radius, and here it says that is acted upon by a torque consisting of two equal and opposite forces. So suppose this is a force F1 and this is a force F2. This F1, this F1 and F2 are equal and opposite, and for this T1 and F1 and F2, it creates a torque, and it says that opposite forces applied tangentially to the rim of the from the extremes of a diameter, and this is the diameter, the extremes of a diameter. And the second part says that the disc is free to rotate about an axis passing through its center. This is our axis, and disc passing through its center, and disc after 2 seconds okay, this is extra things. So it will be rotate an axis passing through its center and perpendicular to its plane. So this is our plane and our axis is perpendicular to its plane. So our first question is, what should be the magnitude of each forces so that the disc may rotate with an angular acceleration of 20 radian per second square? So our angular acceleration is 20 radian per second square. And another point is, what is the kinetic energy of our transfer to the disc after 2 seconds? What is the kinetic energy transferred to the disc after 2 seconds? So in our first part, so we have to solve So in our first part, we have to determine what will be the angle, what should be the magnitude of each force. So we have to find out the magnitude of the each force so that the disk may rotate with an angular distance of 20 radian per second square. We know for torque tau equals to I alpha. We solved this problem in our previous problem statement. So first of all, our alpha is given. So what will be our I? So now we have to find out our I. Here we can see that I is our moment of inertia, and moment of inertia depends where our axis is lying on a body. For that scenario, when a disk is moving or rotating, at that scenario when an disk is rotating about an axis which passes through its center, at that case our moment of inertia is equals to half of mr square, half of mr square. So for moment of inertia we'll write half of mr square, and our alpha is given. So if I put all the value, I will get half of our m is 0.1, r is 0.2 meter, 0.2 whole square, it will be 0.2 whole square, 0.2 whole square into our alpha is 20 radian per second square. So if I calculate whole value, I will get 0.4 Newton meter. So I find out our torque tau, but I don't need to find out what will be our torque. I have to find out the equal force should be the magnitude of each force. So what should be the magnitude of each force? As so, if I want to find out the magnitude of the each force, we know for torque tau equals to r cross f, or you can say that fr if we represent in magnitude, f into r. So I have to find out this f. So there is two f, one is f1 and one is f2, and they have distance which is equals to the diameter, and here our diameter equals to twice r. So instead of f I will write f1, and instead of r the radius vector I will write twice r, because they are far twice r from each other, because this is twice r equals to our diameter. So we can write for f1 equals to torque tau by 2r, which is equals to torque tau. We find out tau equals to 0.04 and 2 into 0.2, which will be equals to 0.1 Newton. 0.1 Newton. So this is the value of our each equal force. So this is F1 equals to, we can say that F2. So this is the force applied, equal force applied to create a torque in that disk is equals to 0.1 Newton. We find out our first part of this problem. Now coming to the second part, it says that what is the kinetic energy transferred to the disk after 2 seconds. So let me remove some part. For the second part, we are given a time, and our time equals to 2 seconds. Our time equals to 2 seconds, and we have to find out the kinetic energy transferred to the disk after 2 seconds. So first of all, we have to find out what will be the value of angular velocity. So angular velocity omega after 2 seconds. And we know, as there is no mention of initial angular velocity, so we take initial velocity omega naught equals to 0 radian per second. So we'll write omega equals to omega naught plus alpha t. As omega naught is 0, we can write omega equals to alpha t, which is equals to our alpha equals to 20 radian per second, our t equals to 2. So it is equals to 40 radian per second. So uh, we find out our angular velocity omega after 2 seconds. After 2 seconds. So now we have to find out the kinetic energy. So the kinetic energy is equals to, the value of kinetic energy is half of I omega square. Half of I omega square. It is actually equals to half of mv square. Instead of half of m, we use I omega square. So here we find out our I. Here our I is actually equals to half of mr square, and omega equals to our 40 radian per second. If I put all the values, I'll find out 1 by 4. Our m is 0.1, r is 0.2 whole square, and omega is 40 square. So the kinetic energy will be 1.6 joule. So this is the kinetic energy of transfer to the disk after 2 seconds. That's all for today's video. Hope you understand all the concept of this problem. Please do subscribe to our channel and like this video. Thank you.